So my name is David Carter, and this is a talk called What Difference Does 1 Tonne Make? So what this is about is that we hear every day about the huge quantities of greenhouse gases that we're adding to the atmosphere and how these emissions have to be reduced rapidly if disaster is to be averted. And we're often told we've got to reduce our own carbon emissions. Yet our individual actions seem quite trivial compared to the global scale of the problem. And it's tempting, isn't it, to leave the climate crisis to other people, governments, businesses to sort out, or to despair about it, or simply to switch off. But what if there was a way to estimate, even very approximately, what the impact is likely to be on people in the future of your or my choice to do or not do something that would generate, say, 1 tonne of carbon dioxide emissions. Now, we make such choices all the time in the way we live our lives, but does that extra tonne matter a lot, or a little, or does it not matter at all? So I originally gave this talk on a day when thousands of school children, in fact it turned out there were over 1 million, were going on strike for a safe climate, taking the morning off school without permission and marching for their future. And this talk is going to present the result of an informal one-man research project, mostly conducted on the backs of various envelopes, just to see how much what we do now matters. So let's see how we do. So welcome to the climate strike. If you haven't heard about it, it was big, and it will probably get bigger in the future. On the right-hand side of this slide, you can see Greta Thunberg, Swedish teenager who came to prominence last year, particularly when she spoke at the World Economic Forum in Davos, where she told all the world leaders they had to stop messing about and get on with sorting out the problem. She said she wanted them to panic because the house was on fire and they had to act like it was. And this graph shows what she meant, or part of what she meant. It shows the concentration of carbon dioxide in the atmosphere from 1990 to about the present day. And that's expressed in parts per million. So on the left, you can see in 1990, it was about 340 parts per million, having already risen by 60 from historic levels up to that point. And then since 1990, it's risen by slightly over another 60. So we're now on about 410 or 411. And even more worryingly, the slope of the line is increasing, which means we're not emitting fewer quantities of carbon dioxide, as you might think, since there was that big agreement in Paris a few years ago. We're actually emitting them more than ever. So we're making the problem worse faster. This is clearly not good. And to express the urgency of this, I'd like to play a short video which expresses it much better than I could. It's got children in it, and I think a lot about my own son, who's 12, when I think about this stuff, because all of this climate crisis is going to play out over the course of his lifetime, and I think it's going to be quite dramatic.
I'm 7.
7. Huh?
When I'm 8, I'm gonna be this tall.
When I'm 9. When I'm 10. I'm allowed a phone. When I'm 12.
I'll get a hairy face.
And when I'm 19.
Scientists will say the world has got too hot.
We burnt too many
fossil fuels.
Driving cars, flying planes,
eating meat, and making rubbish.
It'll get hotter and hotter.
When I am 30,
all over the world,
we'll be running out of food. Millions,
maybe billions. More people be running away from fires and storms. Scientists say
when I'm 57,
lots of New York
could be underwater
if we don't do something.
When I'm old, like 59,
there might not even be a world I can live in. I don't know what I'm saying.
Because Mummy and Daddy didn't want me to.
Be scared.
But you know what I'm saying.
You're a grown-up, so please act like one.
So I can be one too.
It's not too late. But you have to do something now.
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 Now!
To protect me.
Because I'm 7.
So are we going to... So this slide shows how I think about how the current century that we're in might work out. I've called it the road ahead. This is the bottom half of the cover of a book by Bill Gates from a few years ago. He's quite an optimistic sort of guy. I'm rather less optimistic. Our current system is unsustainable. Now, I'm sure we're quite used to hearing that, but if you think about what the word means, it actually means not just that it's unsustainable, but it will not be sustained. So something will happen to stop it continuing, and it's partly up to us what that is. So a lot of people, especially in the tech industry, think that there might be technological fixes which will allow us to carry on more or less as we are. So things like solar energy and drawing carbon out of the atmosphere, maybe artificial meat, things like that, might allow us to continue with our current lifestyles, but somehow avoid wrecking the planet in the process. Now, don't get me wrong, I do think technology has a huge part to play in our future, and we have to really go for it and make the most of it. But I don't think it's going to be enough. So we've left things very late. We've known this crisis was coming for decades, and we've done basically nothing. And I don't think a capitalist solution is going to work, even if it ever was a possibility. So given that technological fixes won't do it on their own, we're going to need some sort of cultural, societal transformation. That will take place as a matter of certainty. The question mark here is about whether it's voluntary and managed or otherwise. So if we do really do what we need to do with the technology and the societal changes, which do have to involve being willing to give up certain habits and enjoyments that we currently have, that could lead us to a transformed culture where we avoid the worst effects of climate breakdown. But if that doesn't happen, there will be a collapse of our civilization and of our ecosystems. Now, collapses aren't always total. They sometimes come in stages. There might be a period of time in between the stages when things more or less carry on in some way before there's another partial collapse. Sometimes they are total, and that depends on a lot of things. So after a collapse or the collapses, will we be able to put together some sort of successor society? Will we be able to partially recover? Would certainly hope so, but it's by no means certain, because as I'll make clear in a moment, the risks are that we will put so much greenhouse gas into the atmosphere that we set off various tipping points which lead to unstoppable climate change, and then whatever we do, we won't be able to survive. The Earth will just become uninhabitable for humans. And you might like to think at this point about how likely you think each of those outcomes are. Maybe you think one or more of them are very likely, and some others are completely impossible. Well, let's see. So this slide shows just some of the headlines that you can find out on the web about the prospect of the collapse of civilization and even extinction of Homo sapiens altogether. These are all from very reputable sources. They're not alarmist or just trying to get clicks. This is serious stuff. So cosmologist Martin Rees, who's one of the most famous scientists in the UK, gives humanity a 50-50 chance of surviving the 21st century. The ecologist Paul Ehrlich says collapse of civilization is a near certainty within decades. Other studies are saying the same thing. How could that happen? Well, catastrophic food shortages seems a severe threat. There's one study which suggests that will happen in a mere 21 years' time. So that's definitely within our horizon of time for nearly all of us. And why should that be? So I've got some diagrams and graphics here from the last full report by the Intergovernmental Panel on Climate Change, which is the main UN body that reports on climate science and summarizes it, usually in a very cautious, conservative way, for policymakers. The last one was about 4 years ago, and already since then things are starting to look a lot more alarming, just because of the weather events we've had and because the climate science has tightened up and we can see certain things we hoped for just aren't the way that we hoped. Anyway, here you can see the projected temperature of the Earth towards the end of this century under two scenarios. So the left-hand one, the brown one, assumes that we do what we need to do, start reducing emissions straight away and get them down very fast indeed, which so far we've shown no willingness to do. If we do that, we'll end up at the end of the century with a temperature rise over most of the world of something just under 2 degrees. Even now, 4 years later, that's seeming a bit over-optimistic, but around 2, say, except you'll notice up at the top, it's red, therefore hotter. That's more like 3 or 4 degrees, and in the Arctic, where of course there's lots of ice, the warming is going to be a lot more severe, and that is frightening because that means ice will melt up there, and white ice, which reflects a lot of sunlight and energy back into space, will turn into dark seawater, which will just absorb the heat. On the right hand side, you'll see a nightmare scenario called RCP 8.5. Nightmare though it is, this is the course which we're now taking. So the emissions that we're currently causing, if we carry on in that way, this is what we're predicted to end up with. So temperature rises of 4 degrees plus all over the world, and in the Arctic it's way even above that. So we're going to lose the polar ice for sure if that happens. Top scientists are saying that climate change will complicate and worsen existing global security problems such as civil wars, strife between nations, and refugees. Here's a summary of projected changes in crop yields. So different studies coming to different conclusions, looking at different time periods. The blue-green bars are for increased crop yields, which is nice. The brown ones are for decreases. So you can see things more or less even out over the coming decade or so. After that, it starts to look severely imbalanced, and there's a risk that crop yields will decrease, and combine that with a rising population, and we have a potentially disastrous effect. So this slide shows the more alarming high emissions scenario that we're currently on, and there are effects all over the world. In Europe, the expectation is for multiple stresses and systemic failures due to climate change in the Mediterranean. This would increase energy costs and damage tourism from 2050. That sounds like the least of it to me. We'll also have to cope with millions, probably hundreds of millions of refugees from all over the world whose countries are even worse affected. And here is why some of these effects might happen. So this slide is taken from a talk that I went to in Cambridge a couple of months ago by Professor Hans Schellenhuber, who runs the Potsdam Institute for Climate Impact Research in Germany. This is probably the best climate science talk I've ever been to. It was really interesting, fascinating, and frightening. And on this slide, he's showing us what the tipping points are looking like. So as the planet warms up, there's a risk that things will change in such a way that certain new things will start to happen, which will cause further warming out of our control. So that's things like the Arctic ice melting, which I've already mentioned, but also stuff like the Amazon rainforest drying out and eventually burning down. That would be a complete disaster. And at even more extreme temperatures, you have things like very large amounts of methane, which is a potent greenhouse gas, being emitted from permafrost or from the sea. And most of these effects, well, they mostly don't appear to be a very severe risk up to 2 degrees, but after that they do. So you can see the yellow turning into red on these bars. And certainly once you get to 4 or 5 degrees, lots of them have kicked in, and we're in a very, very worrying situation indeed. So I wonder how you're reacting to this. Maybe it's a sense of resignation. Yeah, it's grim, but you kind of already know all too well that this kind of story, you've heard it before. So although it's frightening, it's no longer as shocking as it was when you first heard it. Your reaction might be one of disbelief. You might think this is absolutely crazy. If that's the case, I invite you to spend some time researching it for yourself. There's lots of really excellent material out on the web. Look at what the climate scientists are saying. Believe me, they're not lying. They're not telling lies to get more money for their research projects, as the climate deniers tell us. They are very, very bright people, and if they were motivated by money, they could easily earn a heck of a lot more doing other things. So they mean what they say. But if you're skeptical, of course, that's natural and healthy, and do gather the information and decide for yourself. If you do find it's much less bad than I'm saying, then I'd love to know. It would be a great relief. Or your reaction may be one of absolute horror if you haven't seen this before. And if that's the case, I do have a few things which may help just a little bit. So this talk is trying to, as it were, quantify the unbearable, which might seem a bit weird, trying to put numbers on some really horrifying prospects. And if you feel upset by that, then that's very natural, necessary, and inevitable. It shows you've woken up, you're paying attention. If you feel overwhelmed by this stuff, I'll put up a slide at the end of the talk which just points towards some resources you might want to look at. But what I'm basically going to be doing is trying to apply numbers to some of these prospects, things like destruction of our life support system, starvation, death, and possible human extinction. How can you possibly quantify that? Well, I'm going to have a go. Some of it may come across as, I don't know, unfeeling, rather superficial, or at least that there's rather too much bleak humour in it. That's just the way I think, sorry. But I do hope the quantitative analysis can somehow be combined with whatever feeling of shock you have to channel and focus action. The other kind of reaction people have, especially in a group context, if people talk like this, is guilt. They feel got at, they feel blamed, they feel it's all their fault. And it's not. It really isn't. That's not just that it's not my intention to make you feel bad, but a lot of it really is beyond us as individuals. So the first obvious thing to say is what's done is done. We can only make choices about the future. I personally probably have a larger historic carbon footprint than anybody else I know. The reason being, one evening in 1967, when I was a kid, I was waiting to come home from visiting relatives in Germany, back to my home in Britain, and there was fog, and the plane set off from somewhere else. It was going to call where I was and pick up me and a whole lot of other passengers and carry on. They decided not to do that, but then they were told they had to because I was an unaccompanied child. So they were made to do this diversion, landing and takeoff, which must have used a huge amount of fuel purely because of me. So what's done is done. But more importantly, the whole point of this talk is individual choices are important. I'm not saying they're irrelevant, they're important, but they can't stop climate breakdown on their own. Collective action is needed. That means we need to get together and make our voices heard, tell our politicians, tell businesses, tell everyone that things have to be done. And we're not actually individuals, we're not atomized consumers, we're a society, and we need to work together. So let's get numeric. Today's emissions numbers, we saw that rising graph earlier. Here's another version of it that this time breaks it down into different kinds of gases. The previous one was just CO2. This is the whole set of them. So currently we're emitting about 50 gigatons of carbon dioxide equivalent per year. Now what I mean by that, first of all, a gigaton is a billion tons, 10 to the 9, one with 9 zeros after it. And the E at the end of CO2 means it means equivalent, and it means it's all of the greenhouse gases multiplied by a warming effect factor to make them equivalent to CO2. So roughly at the moment we're emitting 50 gigatons of CO2e, which is composed of about, I think, 35 gigatons of actual carbon dioxide, plus other gases which have the same warming effect as another 15 gigatons of CO2. So all in all, that comes to about 7 tons per person. And a small piece of good news, some of that gets absorbed by trees, plants, and so on, which is good. Some of it gets absorbed by the oceans, which is in a sense good for us because it cuts down the amount of greenhouse gases in the atmosphere, but it's not good for the oceans. In fact, it's quite serious because it makes them more acidic. But anyway, if we emitted only 3 tons per person rather than 7, then it would in a sense be sustainable. Although really we still need to get things down because we're already way over safe concentrations in the atmosphere. The UN says we need to halve our emissions by 2030 and reach net zero by 2050. We've got 11 years to do that initial halving, which is quite a challenge. If you're wondering what your own footprint is, well, here in the UK, our emissions are about double the global average, so they're more like 14 tons or even more than the average of 7. Some countries it's even more, in many it's less. So you can estimate your own footprint at this WWF footprint calculator if you want to. And it's worth doing that just to find out where most of your carbon footprint comes from, because then you know what's the most important part of your life to address if you want to get it down. So let's make it a bit practical and look at some things that emit roughly 1 ton of CO2 equivalent. So what sorts of actions we take would do that. So one thing we could do is we could eat an average UK diet, average Western diet, rather than a vegan diet for 1 year. And because production of meat involves a lot of greenhouse gases, if we eat vegan, we save a ton. If we eat meat, we emit a ton. If you live 15 miles, that's about 25 kilometers from your work, and you commute to work every day in your own car by yourself, that would also emit about a ton of carbon dioxide. That's just the driving and the fuel that you use by doing that. I'm not counting the carbon costs of making the car in the first place or disposing of it afterwards. You could make 1 economy return flight from London to Cyprus. So that's about 1,000 miles each way. That would emit a ton effectively. So I'm including there what's called a radiative forcing factor of 2.7. That's what the UN recommends. The actual quantity of gas emitted is less than 1 ton, but the warming effect is about that of a normal 1 ton, because strange things happen at altitude, and strange things happen with aircraft emissions in particular. So flying is really quite damaging. Something else you could do to emit a ton is you could wake up on January the 1st with the intention of going into your loft and insulating your house and doing your walls and your windows as well, and then you just don't feel like it, so you put it off till the following January. Then you would probably be emitting 1 ton roughly per person in the house. So that's worth doing if you haven't done it already, although these days most houses are reasonably insulated anyway, so those savings aren't available. There is one form of emissions reduction that I don't recommend at all, and that's to stop breathing. So 3 people breathing for a year, amazingly, emits 1 ton of CO2. So that's just to point out that we can't actually reduce our emissions to 0. Some will be unavoidable. Okay, so that's how we emit it, but that's not really what it talks about. How do we visualize what it is? So I live in a place called Trumpington on the south side of Cambridge in England, and it's used to be a nice little village a very long time ago. Then it was a nice little suburb. Now a lot of it is a not so nice big building site, and this is part of the building site area. You can see a metal fence and spindly looking tree that shows all the signs of having been planted by builders not very long ago, and it's just shot up. And you can see a kind of dark thing at the top of the tree. That is a cat. I don't know how it got up there. I can promise you it got down safely after sitting up there looking at the view for several hours. So that's just a typical scene. That photo was taken during the very hot weather at the end of February in Britain, where temperatures rose above 20 centigrade and then 70 Fahrenheit for the first time ever in February. And most people said that was just nice. This is a normal day in Trumpington with this time an extra tonne of CO2 added. And you see how different it looks? That's right, not different at all. So we can't see the gas. I expect you knew that anyway. But all right, how big is it? Well, roughly a tonne of CO2 takes up the same volume as 2 average-sized houses, which is kind of interesting if you like that kind of thing, but again, doesn't tell us what it's going to do. So let's get down to thinking about that. How do we translate our CO2 emissions numbers to an effect on human lives? Well, it's going to involve multiple steps. So first we have to know how much extra warming 1 gigaton or 1 tonne is going to cause. That's a matter of climate science. And then we have to predict something about human behaviour. How much warming are we likely to cause before we get to net zero, if we ever do? So which of those scenarios that I showed earlier is the one that's actually going to happen through our choices, or will there be another one? And then we have to ask, what's the Earth's carrying capacity as a function of temperature? How many people will it be able to support in the long term for a given amount of damage caused by possible climate breakdown? And if that reduction does happen, when and how fast will the effects kick in? It won't necessarily be immediate. And then we need some way of quantifying human suffering and the fact of lives being shortened or not lived at all. And then we have to think how much we care about different groups of people. There's a kind of official answer, a PC answer, which is that everybody is equally important. But at a gut level, I would hazard a guess that most of us don't feel anything like that, although we may believe it and support actions which work on that basis, which we should. But actually we don't care as much about many kinds of people. And we should be able to put all of this together to estimate how much difference 1 tonne does make. Now, I will give you a number at the end of this process, but don't take it too seriously. So there are going to be lots of simplifications and approximations in what I'm going to do, and inevitably a lot of subjectivity. So I'm going to be putting in numbers that reflect my personal values, and yours may well be different. And in that case, you'll want to put in different numbers of your own. So all of this is not so much a presentation of results as an invitation to do the same sort of thing better, or at least in a way that's more appropriate to you. So how far can we use climate models to decide all of this? Well, we can a bit, but climate models have a few problems for these purposes. They're very complicated, and that means they're hard to get intuitions about. And also, they don't go far enough. So most of them only address the first few questions on the previous slides. They're about physics and chemistry and some biology and ecology, but not really about human sciences, let alone about values. A few of them talk about economics, but that's about as far as it goes. And also, very few of them go far into the danger zone of temperature rise of above 2 degrees. They all say, well, how can we limit things to 2 degrees and what's going to happen if we do that, at least in detail. Few or none of them try to predict human behavior under severe stress or how ecosystem and population collapse might go. So this is technical language for the kind of nightmare scenarios I referred to earlier. Will we all turn into zombies and start killing each other in the streets? Well, I don't think so. But will there be wars? Very probably there will. So people will die who won't directly be killed by climate breakdown itself, but rather by the human response to it. And of course, no climate models, at least as far as I know, address issues of global and intergenerational justice, or the value of human and non-human lives. So that's about how much do we care about different people at different times. Anyway, let's start with the climate science. So the climate scientists tell us that every doubling of CO2 concentrations causes a temperature rise of about 2.8 degrees Celsius. So there's a margin of error on that, but let's take the figure of 2.8. That, for the mathematicians among you, means that there would be a log scale of temperature along the horizontal axis and concentrations along the horizontal axis and temperature rises vertically. But we can linearize that. We can turn it approximately into a straight line over the range that we care about. It's going to make the calculations easier. And then it comes to there's about 1 degree rise predicted for every trillion tons, 10 to the 12 tons, that we emit that stays in the atmosphere. And I say stays in the atmosphere because we know that currently for every 9 tons we emit, only 4 of them do stay in the atmosphere. 3 get absorbed by vegetation and 2 are absorbed by the oceans. Now, at the moment, the plants and the oceans are keeping pace with the emissions in the sense that they absorb the same proportion. So as the concentration goes up, they're absorbing more. But there are reasons to suppose that that process may fail at some point. They may stop absorbing more. For example, if we have a lot of drought and there is just less vegetation around, then obviously the absorptions will go down. So I'm going to assume that 4/9 will, at least as far as our extra emissions are concerned, will become about 7/9 instead. So we'll lose roughly half of the sinks. And then how much warming are we going to get? So looking at the right here, this shows people's sort of alleged journey from climate denial to climate skepticism to realizing, oh dear, and eventually being really upset. I've blanked out part of that word, although I'm sure I don't really need to. You can see what it is. So you go from climate change isn't real to climate change is real, because we can now see it, of course. We're just not concerned we're not convinced it's caused by humans, to realizing that it is and it's serious. And I've copied those colors over onto the left. So how much warming will we get? So there are 3 possible answers there. The first one is optimistic. From the point of view of this question, it's equivalent to denial, but of course it doesn't have to involve any denial at all. It might just involve an extreme optimism that yes, climate change is real and serious, but actually, now we understand it, we're going to do what we need to do, decarbonize, and the warming will kept to below 1.5 degrees, which is where the scientists think the really bad effects will start to kick in. Then there's what I'm going to call the red zone through the rest of the talk. This is the zone where every ton we emit does matter because it'll make the effects of warming worse. So supposing we are going to eventually end up with between 1.5 and 4.5 degrees, then we will survive as a species, but things might get pretty bad depending on how close to 4.5 degrees we go. And that figure is something of a guess, but I think it fits in with the evidence of the research on tipping points that I showed you earlier. And then there's pessimism. So this is the belief which I harbour myself at some of the time, that we will never effectively limit emissions. So we will exceed more than 4.5 degrees of warming. We will cause the really scary tipping points to take place, the positive feedbacks, and will eventually go extinct. So you can see what's going on there in the graph at the bottom, really. Warming and carrying capacity. So to explain carrying capacity a bit, the carrying capacity of an ecosystem, the Earth in this case, is the number of individuals of a species, us, that can be supported indefinitely in a given set of environmental conditions. So if carrying capacity is exceeded for too long, there will be a population crash. Human beings, with our current behaviour, which could change of course, are already well over the Earth's carrying capacity. You may have heard the phrase, we're using 1.5 Earths, which I think is probably a fairly cautious estimate actually. So there are about 7.5 billion people on the Earth today. You can see in the graph at the bottom there's that red splodge. We are here. So we're already about 50% above carrying capacity, which I'm taking to be 5 billion. And I'm assuming on this graph that carrying capacity will drop in a straight line from 1.5 degrees of warming to 4.5 degrees, at which point it's 0 and we are sooner or later all dead. Question 4. When and how fast will the effects of warming kick in? So as you've just seen, we are over carrying capacity and we have been for quite some time, but we haven't seen the kind of real global disasters that I've been talking about. So being over carrying capacity is kind of okay for a while. It's like spending beyond your earnings, which you can do as long as you have some money in the bank, but eventually that money runs out and then you're in more serious trouble. So eventually, if carrying capacity drops below the current population or stays below it, then the population will go down. We don't know how soon this will start to happen or how fast. Fairly obviously, later is better. So that's because if this happens later than we fear, we might by then come up with some great technologies or some big cultural changes, which would effectively increase the Earth's carrying capacity because we would be a species that would be living more likely than we currently do. There's also the gloomy prospect that something else might wipe us out first. So nuclear war, epidemics, rampant artificial intelligence, asteroid strikes, who knows. Something else might do for us, in which case climate change would have turned out not to matter in the end. And also we might care less about the more distant future, and I'll look at that in a moment. Also fairly obviously, a slower crash or a slower drop in carrying capacity is better. If it's really slow, we might be able to manage it by reducing birth rates, which would be a lot less unpleasant to go through than the alternative, which is people dying before their time in large numbers, which is what happens if carrying capacity suddenly drops and we can't cope with it. And you see both of those things happening in nature with other species. Question 5, how do we quantify suffering? Well, the answer that people most commonly give to this, I guess, is a thing called a quality adjusted life year. People use this a lot in medicine, in sort of medical decision making. So the way to understand this is if you imagine some very bad and permanent but non-life threatening thing that might happen to you. You can probably imagine all kinds of things, but something fairly appalling, but it wouldn't actually kill you. And think how many more years you expect to live. So you might, from where you are now, you might have a life expectancy of 50 years, say. And then ask yourself, well, if I know I'm threatened with this nasty thing, how many of those years of my life would I be willing to sacrifice to prevent that happening? So let's say it's bad enough that I'd rather live 30 years without this thing happening than 50 years with it. So I'm sacrificed 20 years, or 40% of the years I've got left. And then if that happens, if the bad thing does happen, you will live your full span of life, but you'll have lost 20 quality adjusted life years. Or in other words, your quality of life is 1 minus 40%, which is 0.6. So that's kind of putting a number to life being basically okay to life being not worth living at all, and it can be at any point in between. To make that more concrete, this is just to introduce you to a condition and a charity which I think are really worth supporting. The charity does some great work. It works with women mostly in Africa who have a condition called obstetric fistula. You may never have heard of that. If you haven't, it's because it's something that hardly ever occurs in the rich part of the world, because we know how to treat it and we just do, or we prevent it happening in the first place more often. What it is that when women, especially very young women, give birth, sometimes things go wrong and they get a hole or a fissure between their vagina and either the bladder or the rectum. And this won't heal up by itself. They'll just leak for the rest of their lives if it's not treated. And that can cause a really bad smell the whole time, lifelong misery, and often people won't want to have anything to do with them. They'll be ostracized. So their quality of life is very severely affected. So let's imagine one of these women with 50 years left to live, and her quality of life is halved, shall we say. So she's lost 25 qualities. Now the good news is that this is entirely fixable. Surgery and rehabilitation in the form of setting a patient up with their own business, say, with the tools and the skills. The total cost is about £1,000 per patient, which I think is a fantastic bargain, because it comes to a cost per quali of about £40, okay, 1,000 over 25. Now, how much would you give not to have that condition for a year? A lot more than £40, I bet. So there's a charity in the UK, there's a charity called Freedom from Fistula. In the US, there's the Fistula Foundation who do similar work. And then question 6, how much do we care? So I'm sure you've heard the phrase charity begins at home. When people say that, I find what they nearly always mean is charity ends at home. So here's what you may recognize from your maths education as a Venn diagram. You can see a little gravestone at the top right there. This is the gravestone of John Archibald Venn, a Cambridge mathematician who developed the Venn diagram. He's buried about a quarter of a mile from where I live in Trumpington, so it's not just famous for building sites and cats in trees. It's got some history as well. Anyway, this Venn diagram shows the intersection of 3 categories of living beings. So the top circle is humans. The bottom left we have creatures, whether human or not, who are in some sense here, so near me. You see I'm right in the middle. And the bottom right is now, so that distinguishes between people and animals here or otherwise who are alive now versus those who will be alive in the future, or who might be. And right in the middle, so when it says me, think of this as yourself really. And I gave this talk to an audience initially, so I put you lot, but just think of that as the people near you that you care about, that you see every day, that you have some definite connection with. They're in the center of your world, and you care about them quite a bit. Slightly further away, there are people in news reports. So humans, and now, but not here. They're somewhere far away, who we don't know. So I'm recording this the day after the news came out of the horrific mosque shootings in New Zealand. Now that's thousands of miles away from where I live. I don't know any of the people involved. I was shocked when I heard about it. I felt quite upset, but I didn't feel really, really upset. I would have felt a lot more upset if it had happened in the town where I live, and vastly more upset if it had happened to people I know, or right in front of me or something. So at a gut level, I care more about people at the center of the circle than on the outside. Towards the left, you see it says my future grandkids. So these are people who have a strong connection to me, and obviously they're human, but they don't exist yet. They're not in the now. And I do care about that prospect, but I don't care about them individually because I don't know who they'll be or even if they'll exist. So it's kind of a bit abstract. And then at the bottom it says my cat. I have a cat too. It's not the cat who was in the tree. He's got slightly more sense, although not very much. Not human, but here and now. I do try and look after him. I'm fond of him, but I wouldn't value him above any of the people that I know, obviously. So subjectively, my world population size, if you like, is probably quite a lot less than 7.7 billion in terms of how much I care. 7.7 billion being the actual world population. But if you think from the point of view of a world body like the United Nations, or even from a very large government, it ought to be more than 7.7 billion, because it's not just that they have a duty of care towards every person in the world, it's the non-humans and the future people as well, so it should be a big number. So it depends on your perspective. So finally, we're almost in a position to estimate an answer to the question. So I'm going to throw in some numbers, some of which I've shown you already, some of which I haven't. And I'm going to cut some corners. So I'm going to guess, as I said, that 7/9 of our future emissions will stay in the air. And of that, there'll be 1 degree of warming per trillion tons. I personally am very pessimistic we'll manage to stay below 1.5 degrees of warming. I'll give that 1 chance in 1,000. And I think it's about 50-50 whether we manage to emit less than 4.5 degrees or actually go beyond that. So we've got 50% chance of being in the red zone, having trouble but surviving. And I'm going to guess the carrying capacity goes like that graph I showed you, a straight line from 1.5 degrees to 4.5 degrees. And in terms of speed, I'm going to assume that if we do have a population crash, it'll happen fast enough that reducing birth rates won't be an option, and soon enough that I'll care about it as much as if it happened very soon. But I'm also going to assume that it'll be late enough, maybe a few decades, that there's perhaps a 20% chance that something else might go badly wrong first, like an epidemic or whatever. And finally, I'll pretend I'm in a sense like the United Nations or whatever. I care only about all current people, and then I'll adjust for that. So here is a plot or a flow diagram really of what happens to my 1 tonne, and I've put my journey of 1 tonne with the my in bold to stress again. These are my numbers and yours will almost certainly be different, but let's see where we get to. I'm sure you can see the answer, but let's go through it. So we'll start with the tonne of emissions. Some of that goes into the carbon sinks and doesn't warm the atmosphere. 0.78 tonnes stay in the atmosphere. Then there's a 20% chance of some other disaster making this tonne irrelevant, but 80% chance that it will be relevant so far. We're left with 0.62, but then it's only really relevant if it turns out that we end up in the red zone, because if we go over that 4.5 degrees, it doesn't actually matter how much we emit over that because we're all dead, however much it is. So because that has a 50% chance, we're left with 0.31 tonnes. And then the climate sensitivity, which is 1 trillion tonnes per degree centigrade, or 10 to the minus 12 degrees per tonne. So we multiply that by the 0.31 tonne, we get 0.31 times 10 to the minus 12 degrees centigrade, which of course you couldn't measure, but that is the figure for 1 tonne. And as a proportion of the 3 degrees centigrade wide red zone, that is 10 to the minus 13. Okay, so it's you think of a little width within that sloping line region, a very, very narrow area. That's 10 to the minus 13 just for my 1 tonne. And then the effect, well, for the whole of the 3 centigrade region, the effect is to impact 7.7 billion people and deprive them of an average of 40 years of life. I'm taking a human lifespan of being about 80 years, and people's ages are distributed all over that range, so we'll say 40 years roughly as an average. Multiplying that by 10 to the minus 13, you get 0.03 human life years is the impact of my tonne. But there are some other things I want to put in. So I've only considered people dying so far. I haven't considered the very considerable suffering they might undergo on the way to their untimely deaths. So I'm going to multiply it by 1.5 because I do think that's a serious factor. And then I'm going to use the same factor for the extinction risk. So for me, the prospect of us going extinct is even more serious and worrying than the prospect of nearly all of us being wiped out, but humanity just struggling through and managing to survive into the indefinite future. I think that would be a shame. I do have some faith in our future as a species. So I'm going to put in another factor of 1.5 for that. And then I don't just care about humans. I care about animals and all forms of life. So I'm going to allocate another 1.5 figure for that. So all of these 1.5s are totally personal to me, totally subjective. Yours will probably be different. Multiplying all those in, we get to a convenient round number of 1/10 of a human life year coming from my 1 tonne. Or if you like, you could switch that around and say if I emit 10 tonnes, that deprives somebody somewhere of a year of their lives in expectation. Okay, so let's make it a bit personal. Let's take this figure of 0.1 for the sake of argument. That's 36 days, 0.1 of a year. And imagine me making my choice. Am I going to eat meat for the next year or go vegan? Am I going to fly to Cyprus or not? Well, if it was me that would lose the next 36 days of my life as a result of doing that, would I still decide to do it? I guess I might. So I can imagine, for example, if for some reason my son was stuck on his own in Cyprus and had to get back to Britain, and it was up to me, of course I would fly out there to go and fetch him without a second's hesitation. If it was to go on a holiday, no, I wouldn't, because I wouldn't want to lose 36 days of my life. And your numbers will be different and your judgments will be different, but there are probably some circumstances in which you choose to incur the emissions and some where you don't, if you follow this along. One can ask a different question. If, as is in fact the case, it's not me that's going to personally suffer the effects of my 1 tonne of emissions, if it's just some future person who I will never meet, if they were to lose 36 days of their life, would I still decide to do whatever this thing is? Well, for most of us, the answer is much more likely to be yes in that case. Because, okay, it's somebody in the future, it's all uncertain, I don't know them, I'll never meet them, there's no direct connection. And that maybe is part of the reason we don't care about climate change as much as we perhaps should. So just playing around with numbers a bit, you can link this stuff in with some of our decisions on medical care and carbon taxation. So you can, as we've seen, you can buy a quality adjusted life year for about £40 with fistula repair surgery. You can make that much difference to someone's life with just £40, which I probably should have said is about $55 US. Carbon taxes need to be at about that sort of level to have much impact on people's behaviour. That's through some economic modelling that's been done. So people are recommending that's roughly what we should be charging to affect people's behaviour. And that means that if you view taxation as somehow valuing the thing that's being taxed, and if 10 tonnes per qualy is right, then a £40 tax per tonne effectively values a qualy at £400, which is quite a bit more than 40, but it's less than 30,000. Now, £30,000 is what the brilliant British National Health Service uses when it's deciding whether to license a treatment, and that's partly how it keeps its costs down. It's why we have better medical care in the US, in the UK than in the US for about half the cost. But that's not what this talk is about. The ceiling is roughly 30,000 there. So think of the NHS or think of the British government. It's there to care about people in the UK. That's fair enough. The UK is about 0.01 of the world, 1%. So if those are the only people that you care about, then instead of 10 tonnes of emissions per quality adjusted life year, you get 1,000. It's 100 times as many. And in that case, £30,000 would be equivalent to a £30 carbon tax, so roughly the same as 40. So in other words, one can say that if the British government is willing to spend £30,000 on a qualy for a British person, they should be willing to do that not just through the NHS, but through carbon taxation on people's behaviour in Britain. And that would obviously, 99% of that would benefit people all over the world. But even so, the 1% of benefit for Britain would be worth it. And that seems to me quite a surprising result. Of course, it all depends on my personal 0.01 human life years figure for my tonne. So conclusions. Has this been worth doing? Is it insightful or is it just a bit silly in the end? It is hard to make these estimates, but I think it's worthwhile, not necessarily because of the end result, but because it really forces us to think things through and take lots of things into account that we maybe don't think about very often. Subjectivity and value judgments are inevitable, as are approximations. And that means it's not really worth making the science part of this a lot more complicated. So using a really complicated climate model, for example, because it won't add that much extra accuracy compared to all the inaccuracy in other areas that we can't get rid of. The part of this that's about how much we care sheds some light on our behaviour. It sort of means inaction on climate change. The way we behave now makes sense in a way. So if you are a climate change denier or an extreme optimist about what we'll do about climate change, or an extreme pessimist, then it makes sense to do nothing about climate change for yourself, because either it doesn't matter or somebody else will do it for you. Or if you're just averagely selfish, then your effective world population size is quite small. You don't care that much about people all over the world or about future generations in general, so why should you bother? However, inaction on climate change makes no sense if you are the UN or even a large government like the US or China. They've got a lot of people that they're supposed to be looking after, and they're not doing that, let alone people in other countries. And you could make the same remarks for other bodies with lots of influence, large organisations, whether governments or not. They should have a large effective world population size and act accordingly. The point about the NHS I've made already. To mention again, fistula repair surgery and other interventions that are recommended by people who work on effective altruism, which is a movement I recommend you find out about if you don't know about it. Those interventions are really good value, whatever the future holds in terms of the climate. This slide is conclusions, but not quite the end, because normally in a technical kind of talk you put future work just before your conclusions, but I'm putting it after the conclusions because the future work really is for you. So most obviously, choose your own numbers for this version of the framework and see what you get instead. And think about why you decide your numbers are different from what I've chosen. You could rework the framework to make it better fit with your understanding of how all this fits together. That's fine. Don't make it too complicated. It would be nice if it could still be kind of worked through in one's head or intuitively understood. Find a way to work in the things I more or less left out. So that would be really good to do. I was very vague about things like the prospect of extinction, animals, and so on. Could we quantify that? Somebody asked a really interesting question when I gave this talk to an audience, which is, could you quantify the effect of things other than individual consumer actions? Could you quantify whether it's worth writing to politicians or joining protest movements or whatever it is? Is there any way at all to estimate the likely effectiveness of that? And I would love to hear an answer to that. See someone have a go at it. You could turn all of this stuff into a nice interactive web page along the lines of the carbon footprint calculators that you see around the web. It would kind of extend those to say, all right, here's my carbon footprint. What's it actually going to do? And you could fill in numbers for that and see what you got. I'd love it if everybody would think and talk about their own choices and make some really conscious, deliberate decisions. So, as we've seen in my case, because of my number, I have to think about which of my avoidable tons of emissions are worth a month of somebody's life. And finally, take action in whatever way seems best to you. And I will use the final 30 seconds of the hour of this talk just to display